Hey guys, it's Mike here. Today we're going to talk about AWS Data Analytics Specialty Exam. This is an advanced exam and of course it requires a lot of preparation. Today we're going to talk about the learning path, the exam itself, all the things that you need to know in order to pass this valuable and industry recognized certification. Before we actually start talking about exam, I have three updates for you guys. The first one is if you want to get updates regarding future courses and coupons, join the mailing list. The link is in the description. Also, if you want to support the channel, consider becoming a Patreon. Also, the link for merch like this t-shirt is in the description as well. Thank you very much. I really appreciate it. So now let's talk about the exam. So as usual, we're going to talk about the exam in two different sections. We're going to talk about the preparation and the exam itself and the question, the number of the questions, and then the second part I'll walk you guys through all the topics and technologies that you guys need to prepare for in order to achieve this valuable certification. The companies really need people with the specialties, with the skill to help them get business insight, to understand their customer base, to react accordingly to the markets and scale their business in order to become more successful. So we are collecting a lot of information. IoT devices, like imagine Tesla. Tesla is sending on a daily basis terabytes of information to their infrastructure, and those information will be processed in order to understand the user behavior, to make a better car, to advance the intelligence in the car. Imagine I don't know, like ride-sharing companies, they want to understand the most profitable areas. And the learning path for this exam is basically can be from AWS associate level. If you are a solutions architect associate or developer or sysops, definitely you can start working on your big data if that's your ultimate goal. But definitely I recommend you guys pass this associate level first before taking this exam. The difficulty of this exam is it's close to pro level solutions architect professional and maybe DevOps, kind of similar to DevOps. It is a tough exam, and there's a reason for that, right? So the exam is 180 minutes. If English is not your first language and you're doing through online proctor like Pearson VUE, you can definitely request 30 minutes extra, and you will end up having 210 minutes. The questions are long, and they're very, very complex in terms of the depth of the knowledge. This exam will basically definitely go through all the details that AWS thinks it's required to pass this exam. So definitely prepare really well, schedule the exam, but take the practice one before actually sitting in the real exam, because again, this is not an easy exam. Schedule it for early morning, and don't drink a lot of water and coffee 3 hours before the exam, and get good night's sleep. Review all the documents and everything the night before, but get enough sleep, at least 8-9 hours sleep, to be really, really prepared mentally for this challenging exam. Well, the cost for the exam is $300. This is the basically new version of the big data AWS exam. I passed it about 2 weeks ago with around 800 score. It's a very, very tough exam. There are resources. I mean, the best one for me personally is always AWS documentation. They really offer great quality material so you guys can understand any topic on AWS documentations. Remember that. The second one is AWS blog, and where they also release big data and definitely use cases that you guys can look into. You will see those questions and those topic and challenges in the exam when you're sitting in the exam. You will actually, even as you're reading the question, you imagine, okay, this is the ride sharing company that I know of. Oh, this is the media streaming company. These are real life scenarios that you will see in the exam, and they're really useful in terms of big data. But AWS offers a great collection of tools and techniques in order to deal with big data. Companies are collecting all the information, and with the help of these tools, they will be able to process them and make them useful for the business. The exam covers 5 main topics. The first one is actually collection. So we're going to talk about data collection in more detail, but you have to think about the first phase of big data is always data collection. This data collection can be via IoT, can be wearable devices, can be web logs, can be search results. So these are the things that will be streamed to the cloud. So the second one is actually ingestion. So you need to understand how to collect data from device and how to send it to cloud, which is going to be a pipeline of data going from the source to destination. So data collection, then we go to data ingestion. There are very, very great techniques we're going to talk about as far as data ingestion. Now, when you receive the data, you want to store them somewhere. You want to persist them so you can refer to those data. You can have a history for compliance for many different reasons. You might want to process them in different time frames for different regions. So you need a solid place to store your big data. You want to start processing those data. We're going to talk about EMR, Glue, Athena, and technologies that you can use in order to process your data and make them actually usable. And at the end, you want to store them maybe in data warehouse, something like Redshift. At the end of the day, when you query all these things, you want to visualize this data, right? Let's say you have a company with 2,000 retail locations. You want to understand your user base. You want to understand their purchasing behavior. You want to understand the limitations, the good products, bad products. So these are a lot of information. You can't just go and query your main database, your live production database. You need to create data warehousing. You need to move the data from OLTP, which is an online transactional process like SQL Server, where you are doing invoicing, you're basically doing ordering online real time. But you need to move those data after a while to your data warehousing system so you can query and create charts, visualization, and basically process them from big data perspective. So now let's talk about data collection. So there are three major ways for data collection. The first one is IoT. You can send information from, let's say, thermometer, like to cloud. So you have devices, you have sensors that are constantly sending data to cloud. So that's one way of collecting data, like collecting weather information, like around the globe. Correct. So the second one will be basically kinesis, that you can collect data using Amazon Kinesis. It's a technology that helps you collect data and stream them to the cloud, right? Real time and near real time. We're going to talk about that. And the last one, of course, is SQS. You can use queues. Let's say you have an ordering website that people go, or let's say you have a banking system that people log in, they want to get some transactions. They send the request to the queue, it goes to the queue, and then it will process by a backend servers, and the result will be returned to the user in a separate queue. So queues basically will help you decouple your applications where you don't want the user to wait for the process to end. So you can just pump everything to the SQS and then have auto scaling group to process those queues and then send the result back to the user in a separate queue. So your front end fleet can read from the output queue basically. Kinesis, let's talk about Kinesis. Kinesis is it comes with three different technologies. The first one is Amazon Kinesis data streams, where you basically real-time stream data to cloud, and you can send the data to other systems like AWS Lambda or AWS Kinesis Data Analytics real time. So remember, whenever you hear the word real time, it means Kinesis data streams. That's the only technology you can use in using Kinesis to stream data real time. Kinesis Firehose is another technology for streaming, but it has a little bit delay. It's not real time, it's near real time because the minimum number you can set for processing data is 60 seconds, which is a minute. So if you don't care about really real-time result, you can definitely use managed system like Amazon Kinesis Firehose. Firehose can export data directly to Amazon S3, to Redshift, to Elasticsearch, and Splunk. Remember those four because you will see them in the exam. So imagine I have an IoT device that's collecting, I don't know, let's say temperature information, and those temperature information will, I'm sending those to Amazon Kinesis Firehose, and Firehose is kind of storing them into S3 so further processing can happen. I can do other things with that data set later on. Or you can send data to Amazon Kinesis Firehose, and Firehose can send them to Elasticsearch. So you can search them near real time. Let's say you have a weblog and users are basically working on your website and you're sending that data to Kinesis Firehose. The good thing about Kinesis Firehose that you don't have to deal with anything as far as scaling, as far as managing the service, because it's a managed service. Amazon takes care of everything for you. However, if you really need real time, let's say you are working for a healthcare, you have a medical device implanted in someone's body, and you definitely want to make sure you get really real time information. Otherwise 60-second might be really too late. So if it's really sensitive topic, then definitely you have to use Amazon Kinesis data streams. When you work with Kinesis data streams, the way it works, it consists of many shards. You can create shards. Shards are basically channels in Amazon Kinesis data stream that you can send data and they can receive them. However, they do have limitations. Shard 1 Mbps or 1,000 requests, basically in write capacity, and the read capacity is 2 Mbps. So if you need more shards, if you need to send more data to Amazon Kinesis data streams, you need to calculate how many shards actually are needed in order to process. Otherwise, it will be throttled. So what you need to remember here out of Amazon Kinesis topic is the only difference between Kinesis data streams and Kinesis Firehose is Kinesis Firehose is a managed one. However, the Kinesis data stream is something that you need to manage. If we're getting exceptions and you're getting a lot of data and your Kinesis data streams is not able to keep up, then it means you need to scale your sharding. However, creating randomized like keys will target shards in a kind of balanced way. Otherwise, if you have a hot shard, you're sending all the information to only one shard. So you're going to basically hit that maximum of 1 Mbps. In order to scale your shards, you can divide a shard into 2 sections. So that will become basically 2 shards and it will increase your capacity. So however, you have to be careful when you're scaling your shards because you are paying more because you are adding more shards. And so imagine you have patient that's, the person has, something connected, the device is monitoring the heartbeat, for example, and it's sending data directly to AWS. So what is happening, you are receiving the data using Amazon Kinesis data streams in real time, and you have the capacity, you have the right design in order to ingest this data. Now, you want to say, okay, on the fly, if the, heartbeat is over, let's say 80, I want to get notification and send notification, for example, to the doctor or to the hospital. So what you want to do, you can aggregate all these on the fly using Kinesis data analytics, and you can search and you can do queries, SQL queries, and find out what's going on the fly, on real time. And then you can trigger Lambda function, for example, to send SNS. Kinesis data stream is not a cheap service, but it's a very useful and strong for the right use case. So we talked about real time, we talked about near real time, and also we have the batch, which is basically a slower process where you put the data in S3 and then move it, for example, to DynamoDB, something like that. So AWS Data Pipeline is one of them, which will help you. It's a pipeline. It doesn't do anything else. It's just a pipeline to move data from point A to point B. And you can use AWS Snowball, Snowmobile, and recently they announced Snowcomb. So these are the technologies that can be used. For example, you go to Amazon Web Services and you order one, a Snowball device, and then you get the Snowball. You move your data, you connect it to the network. It's completely encrypted, and then you load the data, and then you send it back to Amazon. You ship it back, and they plug it to the network and load the data into S3, for example. If you have a lot of data, that definitely, and the time is not that sensitive, you can definitely use services like Snowball to transfer your data to cloud. So these are all the techniques that we use in order to collect information from the end user, from the end system, from our customer facing application, and move them to the cloud. So AWS Kinesis, which consists of Kinesis data streams, data firehose, and Kinesis analytics. And also we talked about SQS and batching systems like Snowball and Snowmobile. So let's talk about the next topic, which is storage. So as you guys know, S3 is an object-based storage. It's not block-based. So basically, you cannot install database on S3. You can only have flat files like PDF, images, HTML files, things like that. You can store on S3. S3 doesn't have any hierarchy. So basically, when you see the folders in hierarchy, it's not actually that way. It's just a representation. S3 is a flat storage where you put your information, and it has 11 nines durability, which is amazing and fascinating. So S3 offers a lot of different storage classes like infrequent access. If you have like backups that you're not going to use them on a daily basis, you can upload the file and change the storage to infrequent access so you can save money. S3 standard basically offers the most reliable, and it's good for hot data. S3, intelligent tier, that where they basically figure out, if you don't know in advance how you're gonna basically deal and rotate the data, AWS will figure out a model for you and will move the data in order to save costs. You have Glacier for your storage, like let's say your backups can go to Glacier for compliance, and you can keep them there. And you have also Glacier Deep Archive, which it goes really, really deep and becomes really cheap for compliance. If you have the data, let's say you have to keep it for 10 years, 20 years, that's the best place to keep your data. So what you want to understand out of S3 data model is you'll see questions that say, hey, the company is sending all these information to cloud. Now, after 90 days, they don't need this information. So you need to understand how lifecycle policies can be applied to S3 objects in order to save costs and also make the data available in case of any disaster or in case of any compliance or reporting things. For example, you see, oh, this data is definitely needed for 3 months. So you know immediately that you cannot move that data to Glacier before, for example, that time. So make sure you read about S3 consistency model, eventual consistency in strong consistency, and make sure how it works, because you will see questions in the exam regarding that section. S3 Select and Glacier Select, two topics that I definitely recommend you guys look into. So our next topic is about DynamoDB. It's one of my favorite topics. DynamoDB is a NoSQL database at scale in a single millisecond, and it really works. It really performs well if you design your tables properly. Imagine we're designing a voting application for a TV program called The Voice. By the way, I'm not sponsored by them. I'm just giving you an example. So you have 10 candidates, and people are going to vote and send their, let's say, vote through, Amazon Cognito or any type of authentication. They're going to log into the app using their phone, and they're going to vote, right? So let's say one of these performers becomes really, really popular, and everybody wants to vote to number 2. So what's going to happen, you're going to end up having a very, very hot partition in your DynamoDB table. Well, DynamoDB table, it works based on partitions. So you will get 1,000 write capacity and 3,000 read capacity based on for every single partition. Let's say you partition your table, you design your table, and your table starts throttling. People will get errors. So you're asking yourself this question, that this table has enough capacity, why is it still throttling? The reason is the hot partition. So you always want to make sure in DynamoDB, when you have, for example, 4,000, let's say, write capacity, that will be shared between 4 partition, guys, because at most every single partition can handle 1,000 writes, right? So however, your table has 4,000 and you're saying I have 4,000 write capacity, but it doesn't perform well because that 4,000, it's basically shared between 4 partitions, because again, at most your DynamoDB partition can handle 1,000 write requests per second. So if you have a very famous or popular person in the show and everyone is trying to vote for that person, you are basically dealing with 1,000 write capacity because everybody is referring to that specific partition, although you have 4,000 write capacity. Right. So really, really understand this part really well, because it's going to come up in the exam. It's really important in real life design when you're dealing with DynamoDB partitioning. So the way that you want to design your DynamoDB table is always you want to add a randomness. If you have 10 people in the show, you can add a random number between 1 and 10 to every single request to your DynamoDB. That way, you will randomize your incoming requests to DynamoDB, and then they will be evenly distributed between the partitions. So guys, this is a very, very important topic. Please go read in more about this topic. But the idea is having the right random key for your DynamoDB table will distribute the traffic between the partitions, so your DynamoDB table will not suffer. Right. So make sure you understand about DynamoDB streams, and streams are basically when you change something, you can set up, okay, I want to have before change and after change, what happened, what changed. So you will get, then you can have Lambda function react to those changes in your DynamoDB table. Make sure you have a good understanding about LSI and GSI. Let's say you have a voting table and you want to basically, let's say, for example, query based on genre, right? So you can add that secondary local index or global index to query your table. However, you need to pay attention that local indexes, when you create local secondary indexes, it's just happening during the table creation process. And if you need to add something later on, you need to add global secondary indexes. The next topic is AWS Glue and Athena. So Glue is an amazing service in terms of ETL and data discovery, schema discovery. Basically, Glue is a serverless schema discovery service. Let's say I have a CSV file that I uploaded into S3 that contains all the order information from Amazon.com, right? And then I want to understand the schema of this data. You can run AWS Glue for that S3 bucket, and Glue will go ahead and explore the discovery. It will come back, it will tell you, okay, I have an order ID, order date, who ordered it, and the amount and the number. So what you really need to understand here is Glue is just a discovery. There's no actual data in Glue. Glue extracts the data and uploads all the information, all the metadata about the file, about the structure of the file, about the schema to somewhere called AWS Glue Data Catalog. So in AWS Data Catalog, you basically have all the information regarding the headers, regarding the structure of the data, but not the actual data. Then what you can do, you can run serverless ETL jobs using Glue and have the jobs scheduled on a daily basis or based on trigger or on a monthly basis. That once you have everything in Data Catalog, then you can use something called AWS Athena to query your data in S3 using that data catalog. So you will go to Amazon Athena. It says, okay, here's my data catalog. I want to query all the data that order more than $100 in the order. So then you can write SQL style queries on Athena, which under the hood uses Presto, which we're going to talk about in EMR section, to query your data in S3. But remember, AWS Glue is just stores data catalog. You can have ETL, serverless ETL. You can have job bookmark. So the next topic that you will be tested on the exam is Amazon EMR, which is a basically Hadoop framework, managed Hadoop framework. Running a Hadoop framework, if you guys are familiar with HDFS and Hadoop framework, is for big data, used for big data. So make sure you have a very good understanding about Hadoop cluster, how HDFS works, and of course how S3 can be integrated with this cluster. Amazon EMR FS, which is basically, instead of using HDFS, uses S3 for data storage. So you need to understand why Spark it works really well. Spark is an in-memory data processing framework for big data, as opposed to Hadoop, which goes to basically HDFS to reads and writes data to the disk. That increases the I/O operation. That's a very expensive operation. Spark does this in memory. So you might see questions about Presto if you are trying to connect to different data sources. Remember, different data sources. Basically, Presto is your solution. That's what Amazon Athena uses under the hood. Make sure you have a good understanding about HBase. HBase is actually is a technology used by Facebook. They used it for their messaging system when you have a rather random reads. So when you have a Facebook message back and forth between users at massive scale, HBase is basically the solution that Facebook chose to use. So Zeppelin, Hue, these are the things that comes with big data tool. If you take any courses, for your big data exam, I'm not sponsored by any of these guys, but you can definitely use, Udemy, Cloud Guru, and Linux Academy, all the classic, resources for AWS exams. So remember, data pipeline is basically a pipeline to transfer file or transfer data from point A to B. There's no ETL, there's no actual logic. You can just move data around, right? If you have an ETL job, you can use the serverless mode, which is AWS Glue, or you can use EMR with, for example, Spark, that you can launch a cluster, bunch of instances. They're going to go through your data, they're going to chop them, and they're going to work on your data as soon as possible. So based on the amount of data, you need to design your cluster, efficiently as far as cost and of course operation. So I want to talk about a few things before wrapping up this video. One of them is Elasticsearch. Imagine you are collecting all the web logs from your website and you want to query those and see if you're getting, for example, DDoS attack, right, from a specific IP. You want to be able to search those. So Elasticsearch is basically a petabyte scale analysis and reporting tool. It always comes with ELK. They call it ELK, Elasticsearch, Logstash, and Kibana. So Logstash is basically a mechanism for log delivery, and Kibana is used for visualization. So let's say you are helping a car manufacturer to basically have a good understanding about exceptions, and they want to kind of like log analysis system from their manufacturing pipelines. So Elasticsearch can be used for that purpose. So these are tools that you want to give those big companies to process their data more efficiently and quickly. So one very important topic in the exam is, of course, Amazon Redshift. Redshift is a very, very fast, probably 10 times faster than on-prem data warehouse solutions. Easy to manage. It's managed by Amazon. You don't have to do anything. You always want to use data warehouses when you are worried about your customer behavior and you want to have a good understanding about your business. So BI tools, whenever you're talking about reporting massive amount of information, let's say you are working for Walmart, Amazon, Ford, Tesla, you want to have a good understanding about your data. How do you actually query your data? Do you go and query your main database while it's under operation? No, that's OLTP, which is online transactional processing. That's your live database. That's your OLTP. That's for transactional databases. You don't want to do that. You always want to move your data to a data warehouse, OLAP, which is for analytics, and you can start querying your big data. And the reason you want to do that, because Redshift uses a cluster under the hood. It has workers. There's a basically master node that always distributes the work between all those instances, so they can go and do part of the work and return the result to the master. Master puts everything together and returns it to the user. You want to look at all the sales information in Southern California from this state to this state, and for the last 10 years. So this is a lot of data, and if you want to run it on a normal database, it's going to take days. So you definitely need to run these type of analytics on data warehouse, which Redshift will be your choice. You definitely want to look into Redshift plus Redshift Spectrum. If you see questions or scenarios that a company is trying to query current data, but there is like 10 years history that we want to join all this information, you don't want to load that 10-year information into your Redshift. What you want to do, you want to query your current year using Redshift, but you want to use Redshift Spectrum in order to query your result for the last 10 years and merge those and join them and get the final result. So this is the pattern. You use a Redshift for the current year, and you use Redshift Spectrum, which you can actually, which what it does, it goes to S3 and queries without loading data to Redshift. So you will be tested on how to load data into Redshift. Make sure you have a very, very good understanding about copy command and the way that Redshift operates as far as parallel processing. So one more thing about Redshift, about concurrency scaling. If you are working for a company and 100 data, business analysts, they're trying to get a result, and they're reading data from your Redshift cluster, and they're complaining about the performance. Remember about concurrency scaling, how to configure that. Remember to read about workload management. Let's say you have a long-running queries and short queries, so you don't want to put your short queries behind the long-running ones. So you always want to have two separate channels. So workload management will help you get that resolved. Remember, workload management. One thing I want to definitely talk about is distribution style in Redshift. So when you create a Redshift cluster, right? So under the hood, there's master node and there are worker nodes, and you have slices in every single node, right? And as soon as you initiate the copy command, based on the number of slices and the number of files you have in this tree, the system starts copying the files from S3 in a parallel way to your Redshift cluster. So you definitely want to have a very clear, good understanding about Redshift slices, nodes, and the way they will be mapped to S3 files. The way you can unload data from Redshift to S3 will be using unload command. So know the difference, know the techniques, to load data from S3 to your Redshift. And from Redshift, of course, you can use QuickSight. You will see a lot of questions actually about QuickSight, the way you can visualize data from your Redshift. And people want to see, for example, let's say sales information for the last 3 months, that will be only read only, and you can share it with people in your organization. Remember, QuickSight is used for internal users. It's not something you want to expose to external users, right? So you will be tested on this concept. So you will use QuickSight for internal users. Let's say you want to introduce this in a meeting and to your managers, so you can share that dashboard from QuickSight. Know the difference between standard QuickSight and enterprise, which will basically Active Directory integration for enterprise, and you will pay probably double, $18 a month as opposed to $9 for the standard one. So one last thing about Redshift is the distribution style. You have multiple type for distribution styles. Guys, I cannot emphasize this enough. The first one is auto. Basically, Redshift will decide what type of distribution style is good for your data. But it's a very accurate algorithm, but you always want to understand your data better than anyone else. So if you have the data that doesn't change often, right? Like a fact, like a base table. You can use all type, right? The distribution type will be all. Basically, that will be copied to every single node. So when you run your query, nobody needs to go and ask other node for piece of information. So they always will have the local copy of that table in the cluster, right? So all will be used when the table won't change much and the size is limited. You will have an option to pick even. It will basically go round robin. So that will be good when you have no join, basically no pattern in order to get the data in a single place to create complex joins. But if you hear about joins, your best distribution style will be key. That will basically put all the records, all the information that they are referring to the same key in a single partition. So as far as networking traffic nodes, they don't need to go to other nodes and ask for information. So these are very, very important concepts. This is the difference between passing and not passing the exam. This exam, again, it's not an easy exam. It's an advanced exam, and it's a very, very narrow skill set that AWS will really dig into your knowledge and make sure you have a good understanding about all data services in AWS and how they can be used in order to help any organization to achieve a better result. Well, that's it for me, guys, today. I hope you guys liked it. Don't forget to like this video, and I hope to see you guys soon. Thanks and bye.